So going next, may I now invite Mr. Alberto Carrera, Global Technical Director, SCTE from Spain. He will present the domestic waste recycling technology. Mr. Alberto, please. Thank you.
Very much. Perfect. Thank you for the invitation, FitMe, HKPC. I've been really very happy of the organization and to listen all these intervention. Yesterday I was talking to Vicente that is here with me from Spain, and he said, but we've learned about satellite, artificial intelligence, expanded or increased reality, how to produce batteries, how to the automotive sector. And I asked him, but maybe we are not in the right forum, no? Because we are basically recycling garbage, no? In a nice and good way, but and then we have to consider that in reality, all these gentlemen, these scientists, researcher companies, what they are doing, they are just trying to make our life better and try to take some challenges, no? That like the artificial intelligence and human being, you know, living, I don't know if the right word, together. And I said, what we are doing in our field, we are taking the challenge of the cities mainly, no? The entire countries, but the cities. And if you consider which is one of the biggest challenge of the city, apart from energy, transportation, and smart city, you know, we're talking about smart city, waste, no? Waste is a problem. The city of Hong Kong is producing every day 15,000 tons, equivalent to 20 Olympic swimming pool every day. Every day arriving somewhere. You don't know what's happening, most of you, I think, you don't know what happened to the waste once it's out of your house. No? I think in Hong Kong, most of it goes into a landfill, so in the big hole, and in incineration, so destroyed by fire. So nowadays, it's no longer possible. The world is asking not to do that anymore. So you need to recycle, you need to transform, you need to find a way to disappear without affecting the environment, the CO2 emission, etc., and possibly to reuse it. So once I was talking to a mining company in Australia where we have built a plant in Sydney, and they were saying we are doing the same job. Mining is taking the minerals and treating minerals to take a value and have a final product. And I said, yes, maybe you are right, but remember, every day waste is produced. So if every day I'm not able to process waste, the mayor, Vicente, is calling me, very angry, and he said, you need to fix the problem. Mining, it's a problem, it's an economical problem, but the mineral stays in the mine. So it's more problematic to treat waste sometimes than treating minerals in the mining. That's why you need experience. Innovation is very important, but you need to prove in the years that you are capable to treat with large quantity of waste. I have a small video to show a little bit the company, because I think it's important to present the company and understand what the company is doing, the history of a company in this specific domain, the domestic waste treatment. Can you please show the video? Thank you. If 5 years, 6 years, so maybe we have a little bit more years and a little bit more plans. Of course, it's not comparable to the level of automation that you have in many serious plants, but this is mostly customized fabrication. Okay, so this is a little bit of a fly around of the company. Now I'd like to talk a little bit about the technology and the history of the company as well, because I think it's, again, it's important to understand a little bit the history of the company. It is quite important to understand that in the 80 years of activity, more than 200 million tons handled in total, and 75, 80 millions of municipal solid waste. What are the technology that we are using in our company that we are providing to the cities? Or I say city because normally is the city that requires our technology, because we take care about large quantity of waste, which normally a little village has not enough, or a consortium of cities that can be, or villages that can arrive to a minimum 500 tons per day treatment, which correspond at least to 250,000 inhabitants, just to give you an idea of the average size. So mechanical biological treatment, composting of bio-waste. You have a lot of food waste in the city of Hong Kong. Biomethanization, it's well on fashion now, the production of biogas and biomethane from food waste, and post-composting of this fraction. Then you have the biodrying in order to then to provide burning of the material in order to produce electricity. And then, and also you have, of course, commercial industrial waste, RDF, which is refuse derived fuel, always for cement kilns and other production that requires energy. And material recovery facility, which is classically the recovery of bottles that you can do from PET, HDPE, etc., etc. We say young company because the company, Soren Cecchini, was founded in '93, but it's coming from a group which has been founded in 1944. You can see Rome 1964. This plant had 600 tons per day capacity. So it's a remarkable capacity for that age. We are talking about the history of treatment of waste. At that time, plastic film was not existing, for instance. All the bags were made of textiles. Just to give you an idea, plastic bags enter in the waste stream in '73, more or less. So if you can see, we started in 1944. In 64, 70, we had already the first recycling plant, and then we start working in Canada, Brazil, Japan, Norway. In '88, there's the first system of stabilization, biological stabilization of the waste in Italy, patented. And then we continue. In 1993, I started 2 years before working for the company, so it's more than 35 years working in this company that was founded by my father. And then we have a lot of other activities all over the world, Canada, Spain, UK, and Australia. So let's say we have accumulated in the years a lot of experience. In 2010 was founded in Spain, Soren Cecchini Techno Spain, so to have to cover all the Spanish market as well. And just to give you a brief overlook, nowadays we are delivering plants in Madrid, in Sydney, Huelva, which is in Spain, and in France, in Côte d'Azur, close to Nice. And we are continuing many other projects, including IFA in Israel, and Ribeirão Preto in Brazil, a lot of plant in Spain as well. So let's say that we can consider our technology more than industrially proven, because the number of plants are confirming that the technology function. If you can see our reference project, main project list, only on this list there are 60 projects different. And you can see, and this is not because we are particularly good, I think we are, but it's a little bit what is happening in the world nowadays. Everyone is looking for treatment of waste. In the last few years, we have an increase of the construction of treatment plant, which is incredible, because everyone wants now to have a treatment of waste and resolve the problem, especially of the decarbonization. Decarbonization is becoming one of the key leaders of the treatment of waste, and European community is putting a lot of money into that, but I'm sure all the different countries, including China, is considering that a priority. So treatment of municipal solid waste in the proper way, is reducing, is not making zero. As Professor Hu was telling before, it does not exist, but you can reduce it, you can mitigate, you can make that the treatment is more environmental friendly. Let's see a little overview. I don't want to bore you a lot on that, because I'm sure that there will be many other occasions to talk about advantage of the technology. As you can see, all the technology is fully automatic. It's an important part of the technology. When you have large quantity, if you don't go automatic, you're dead. There's no other way to go when you're dealing with the city waste. These are details. I mean, sometimes you imagine that in the treatment of waste there are big inventions that can change the treatment. Maybe there will be, but till now the treatment of waste is done also by good engineering, detailed engineering, starting from the receiving of the material. You need to do a receiving, a smart receiving, in order to be clean, not to have peat to increase the quantity of leachate. You have a big problem in China with leachate, because you have a lot of moisture content in your waste, and you need to deal with it. If you leave in the pit all this material, I went in a few years ago, in 2006 in Shanghai, in Pudong, to see the incineration, and they were treating 1,000 tons per day. That's large plant, and they were producing 200 tons per day of leachate. Why? Because the pressure of all the material, 8 meters, was squeezing on the bottom all the waste, and they were pumping all the time this leachate, and this, because if if the organic matter stays more than 2 days in a pit, the organic cell break down, and so it releases the water. And so they were pumping constantly. And this is a big problem, because, of course, you cannot burn water, and at the same time, you need to treat that water. So making the proper receiving pit, it's dramatically important, especially in country like China. Another little detail, a key that makes a plant running properly or not, we have a feeding from an electric grapple. This electric grapple is capable. It's very little. It's not a huge grapple that you can't select anything, and you throw everything into the oven, for instance, and the oven does not care really But if you have to do the treatment, you need to be like the mother eagle that has to go little by little giving the food of the little bird. And this is the same thing. You have a little hand, well, little, it's a big hand, but it's 1 cubic meter that is feeding the line. And at the same time, as you can see there, you can see here the material which is in that area. These are the bulky waste that it's able to select by the end. The operator, this man here, which is in a very remote, controlled, air-conditioned area, can select all this material. For a city, it's very important because, unfortunately, when you consider, no, the waste is only perfect, it's the little bag that arrives on the receiving platform. Wrong. Because people, whenever have the chance to throw things in the garbage, throw things in the garbage. You can find whatever. And I'm sure that Hong Kong is the same. It's not different from all the other cities I know. So you need to have a certain detail in having such kind of system. It's quite unique. You can imagine that it's quite normal. It's not. Because mostly you have a flat slab or you have a pit. This is an hybrid solution, which works very well, and we have several all over Europe. Another good, important thing on waste is to try to eliminate all the undesirable materials. So you need to suck all these equipment, our equipment which are sucking the air, with the air, all the waste to let down all the undesirable. If you have to do whatever shredding activity or separation activity, if you don't provide wind separator, you have a lot of trouble in shredding because you have a lot of undesirable material inside. This we have discovered in Rome, for instance. We had a huge problem with, washing machine motors. This is why a washing machine motor should enter into the waste stream. I don't know, but you find it inside. Now we have, you know what is the biggest problem now with waste? Just to give you an idea, that with the system you should eliminate batteries. We talked yesterday, they were explaining how to produce batteries. Nowadays, in the waste, the main problem are batteries. And you know why they are a problem? Because battery, when you hit the battery with a shredder or with a feeding equipment, what they do? Most of them, they go on fire. So there are a lot of problems of fires in the modern waste. Why? Because you throw it there, the milling machine, the little electrodomestic, whatever you can imagine. How do you call it? The monopattino. All these kind of batteries are a problem. Even sometimes the telephone one. So with this system, we eliminate all these materials. And then you have a combination of technology, which is, of course, the optical sorting, shredding, differential shredding, trommeling, etc. I don't want to do a lesson on how you do the separation of waste because I don't think it's worth. But just to understand that a plant treating waste is a complex plant. It's not an easy plant. And the important thing is to combine all this machinery in the proper way. You can imagine that one machine makes the work. The work is done by the proper combination of machinery properly designed. That's why you need experience. It's not, I've invented the machine, you put the waste and outside you have the results. Does not exist. Unfortunately, maybe in the future may exist. I'm always long, but I'm Italian, so I think I'm excused because we are known to be always late. The real key of the technology is this machine. It's called the Biomax. Why, you will say, why it's so interesting as a machine? It looks like a big industrial pasta-matic, no? Which is turning whatever you put inside. Well, more or less it's a pasta-matic. It's a giant pasta-matic of 80 tons. But it has a very good characteristic, especially dealing with organic waste, which make, as a company, I think there are only 2 or 3 companies in the world that are dealing on organic waste on large quantity. And this is one of the systems that is used worldwide when treating all this big quantity of waste. It's a little bit academic data. I'm sure it's also a bit boring. But the concept is that you have automatic system where the material enter, it's turned constantly. You have a constant suction of the air from the bottom in order to maintain the temperature, because you want that you have the transformation, aerobic transformation of the material through continuous sucking and turning and adding of water. You basically are replicating nature. You're not doing any miracles, no? The treatment of garbage is not a miracle. It's good industry applied and details. What you want to do, that this material is transformed constantly. It's very accelerated. You want that the process, the biological process, the ancient Roman were saying, natura non fecit saltum, which means nature doesn't not make step. It's a continuous process, no? The nature. And that's what we are doing, the same, but accelerating the process. We are just trying to make the process shorter. What it takes a month, we do it in weeks. And this is the advantage of the system. Why? Because we control all the parameters. Here, again, there are other characteristics of the system. I don't want to bore you, but it's a full controlled process, automatic, and with monitor. We were telling, I can show you here how more or less how it works. You have the system, which is the input up in there, which is feeding this big swimming pool every day, constantly. So, and then you have the machinery, which is starting on the other way to make space for the new material coming and downloading the old material. So what happens? That the material, little by little, transform, becoming from red to green, hygienizing, because I want to control the temperature to make sure that there are no pathogens. Another important thing in waste dealing are hygienization. We know perfectly what's the problem regarding diseases. And waste, unfortunately, bringing diseases. Not because we are putting diseases in the waste, but simply because waste, through the biological process, uncontrolled, are developing diseases, pathogens in general, not only good microbes. So you need to treat. How you treat it, you need to control. If you turn it constantly, if you add the water, if you suck the water, the air constantly, as you can see, this is the, let's say, the biomonitoring that we do on the machinery. We were talking during these days about artificial intelligence, and I remember Patrick was telling one important thing. To do artificial intelligence, you need database, you know? In waste treatment, and we normally, most of the process are semi-automatic. And therefore, the collection of data is a little bit difficult because it's the manual part. In this specific technology, all is automatic. So you can collect all the information without exaggerating. We don't have the 3,000 sensor like the line of batteries, because the problem is that there are, we need to have waterproof, dustproof, so we have a lot of constraint on the sensor. But you can have a certain number of sensors. So we can collect a lot of data. This is our portal where you can see all the data from your mobile. At the same time, we are trying to understand more how to apply artificial intelligence. Why? Because with all this data, the system is capable to control better the biological process, to reduce even the time, and to make that it's repeatable every time the same results. And I think that there are not many technology on the market on domestic waste that can provide that result. A little video. Hope you're not too bored, but I'm more or less okay with the time. More or less okay. So here, just to show how it works, you know, you see that there's a, here you have the free space, and the free space moves in that direction. See? It's moving. So we are displacing basically a hole. Yeah, sorry. we are displacing a hole. So we start from the back, we download the ready material, and we move the space in front, just to let more space available for new material entering. And this is dynamic, continuous. It looks quite, logic. No, not a real invention. But believe me, when you're dealing with hundreds and hundreds of tons every day, to have a system like that makes life to the treatment much, much easier, because you have the chance to have a perfect control of the process. Okay, I think it's enough. Just to end with some facility that I've recently done, just to give you an idea of the size, etc. We have here the latest one. Well, in reality, we are building another 4 of them, but okay, I'm showing you probably the most important in the sense of the position, because it's the city of Madrid. City of Madrid is an important capital, one of the biggest in Europe, and this is taking care about all the food waste of the city. Is recently, in reality, the pictures are not even updated because the plant is running. And I invite you, if you have any chance to come and visit, because it's really interesting, the treatment and the production of, you see all the food waste and the green waste, which are mixed thanks to this material in order to produce compost. Another one, it's always close to Madrid, big one, in which we have also the treatment. Again, you see the biomass and the compost produced, which is an extremely good quality. The important thing is when you deal with the large quantity, you need to assure that the quality is constant. It's not easy when you have small-scale technology. You need to have a large-scale technology automatic, because without automation, you teach me that without automation it's not possible to do any kind of industrial business. No? I've learned in here even more. This is the plant of our mayor, which is Guadassuar, that you have seen yesterday in the video. And this is Barcelona. Who does not know Barcelona? Everyone knows Barcelona. This is a nice plant on the mountains, which is treating one of the biggest in Spain. This is one in France, and it's interesting because look, the position of this plant is in the industrial area. So the problem of odors has been perfectly taken into consideration, because we know perfectly that the environmental impact of this plant are very important. So a city does not want to have any odor escaping from the plant. You can see we are in the close to Nice, in the Côte d'Azur, so it's all luxury, you know, the building, etc., because it's a rich city. And this is in the industrial area in England. You can see this is a big industrial area, and this is a big plant just the side. So again, other problem regarding of environmental impact that has been properly resolved. And this is how it looks inside. Thank you for the attention, and I hope we can provide more information in the future for the city and all the other cities in China. Thanks.
Okay, once again, thank you. Thank you, Alberto, Korea. So we have the audience have questions for you. The first question is, do you think your system is applicable in Hong Kong?
I believe so, but being only a simple mechanical engineer, I need to first to see, and if I don't see, it's difficult to say. But Hong Kong is a capital like many other capitals in the world. We live more or less in the same way. Waste should be quite similar, so I don't see why it's not applicable like in many other cities.
Okay, so the other question is, any reference site in the world that you can just share with us?
But we have several references, have you seen in our presentation, my presentation, especially in Spain. In Spain now we have 18 different sites. We are building for big cities. So I would invite you probably in Madrid, which is probably the best place. It's a capital. So for sure, the authority will be very happy to receive a visit from whoever is interested. And Guadalajara, sorry, Mayor, I don't want to. Otherwise, when I come back, he will be angry with me. No, Guadalajara is a beautiful plant as well.
Yeah. Okay, once again, thank you,
Thank
Mr.
you.
Alberto.
Thank you.
One more questions? Okay, I just give you a mic, okay. Just wait a moment.
What percentage of waste do you process in Madrid, for example?
In Madrid, we have 2 plants. One plant is treating 230,000 tons, which means approximately 700 ton, 800 ton per day. And another one, which is only food waste, which is processing 100,000 tons, which is approximately 300 tons per day of food waste. So the size is a middle large size. When we are talking about municipal solid waste, exceeding 1.5 thousand tons, it's already a plant a little bit too large to be, also because of the logistic, in order to get the trucks getting in the site.
So what is a percentage?
You're talking about the percentage of waste, or the tonnages of the percentage
of waste
diverted,
processed, relative to the waste produced.
The recycle, the total recycle. We normally evaluate that in terms of landfill diversion, which is the quantity of waste that does not go to the landfill, because you can do the best process you can, but at the end, always you have some rejects, residual. And this residual, in our case, for instance, in the case of Vicente plant, is 30%. If it's food waste, it could be only 15% or 10%, depending on the contamination of the food waste source separated. So it depends a lot on the level of contamination and the quality of waste. One of the good important things of the technology is that all the water that is in the waste. In China, we have seen analysis of waste in Henan, for instance, or in Shandong, where you have almost 60% of organic food waste, and therefore almost 60–70% of water inside in the total amount. This system let evaporate most of that water, so this is very good for the impact, the environmental impact, and also from the general mass balance, because you have already probably solved 30 or 40% of the total mass balance is going out like evaporation. So let's consider that at the end you have always 30% of reject to consider. Maybe if you combine this with incineration or with the next step of incineration, which is more focused in burning only biogenic materials, so that are not going to produce CO2 emission, you can even get to the famous 10% that is requiring the European community by 2030, 2035. They will change probably they will skip a little bit, shift a little bit the year. But this is the number more or less.
Thank you.
Okay.
Thank you.
Once again, thank you very much
you.
for Mr. Alberto, Korea, for your insight presentation. Okay, so it's time to take a break. So we will meet you at 4:15. See you.